So in the previous class, we discussed up to question number 20, question number 88. Now we discuss question number 89. So question number 89 given a hinge gate of length 5 meter inclined at 30 degree with horizontal and the water mass on its left side, and the density of the water is 1000 kg per meter. This is meter cube, and the minimum mass of the gate in kg per unit width perpendicular to the plane of paper required to keep it closed. So let's solve this question. Given density is 1000 kg per meter cube and inclined 30 degree. 30 degree is opposite angle 30 degree, and the length of the gate given 5 meter, and we have to found the mass of the gate, which is a minimum mass to keep the gate closed. So this is the hinge and this is the gate. We get the water. So this is the given length given. Five meter, and this is the center of gravity where the total weight the gate is act, and this is the center of pressure where the hydrostatic force act, and this is the datum line where we have to calculate. This is the vertical distance, which is denoted by h bar. And this is the vertical distance of center pressure from the reference line, which is h star, and the angle given 30 degree, which is theta, and this angle also 30 degree, and the center of pressure where the hydrostatic force F at, and the width of the gate is B, which is 1 given perpendicular to the front of the board. The length is 5 meter. So we have to found the area of the gate. Which is length into width. Width is 1 unit, so 5 into 1, which is 5 meter square. Next, we have to found the h bar, where the hydrostatic force from acting. So h bar is equal to, this is 5 meter and the G is exactly mid of the gate, so it is 2.5 meter, and this is theta, so H bar will be 2.5 sin theta is equal to 1.25 meter. Next, we have to find the second moment of area Ig, which is equal to B L Q by bar 12. So B is equal to 1 and L is 5, Q divided by 12, which is equal to 10.41 meter power 4. Next, we have to find the hydrostatic force. F is equal to rho G H bar into area. So the density given water 1000 kg per meter cube, and gravity acceleration due to gravity 9.81, and the H bar we found 1.25 meter, and the area is 5 meter square. So the force value is 6132.5 Newton. So the force value is 6132.5 Newton, and we have to calculate the W value, the mass value, and this is in Newton, so divided by gravity we can find the mass. So this is the O. Next we have to find the H star, where the F act on the gate. So H star is H bar plus Ig sin square theta divided by A H bar. So H bar is 1.25 plus Ig will calculate 10.41 into sin theta is 30 degree, sin square theta divided by area is 5 meter square, and H bar is also 1.25. So in this case we can find the H star, where the center of pressure is act, where the force is act on the point center of pressure. So H star is 0.66 meter. Next we have to balance the moment about O point is equal to 0. So next, F into this distance, F is perpendicular to this, so F is this distance, F into H star divided by sin 30, which is equal to W means mg, m or to pound, and g is 9.81, and the distance is obtained is this distance is 2.5 cos 30. So by solving this, we get mass is equal to 9618.93, which is the closest approximation to the 9625 kg. So the right answer will be option D, 9623 kg. Option D will be the right answer for question number 89. Next question number 90. In a two-dimensional velocity field with velocities u and v along x and y direction respectively, then the convective acceleration along the x direction. The convective acceleration is given by u du by del u by del x plus v into del u by del y. So option A is the correct answer. Next, question number 91. For an incompressible flow field, v vector, which is one from following the condition must be satisfied. So the right answer will be option A. Next, question number 92. A ceiling with a frictionless plunger contain water figure given, and has its end a 100 mm long needle of 1 mm diameter, The internal diameter of the syringe is 10 mm and density of water is given 1000 kg per meter cube. Next, the plunger is pushed in a 10 mm per second. Then we have to found the water comes out the jet. And then assuming the ideal flow, then the force F Newton required on the plunger to push out the water. So I have to found this F value. This diameter given 10 mm and this diameter given 1 mm and the length given 100 mm. This is the needed. So we have to count the force. So applying continuity equation between the point 1 and the point 2. So area A1 into B1 is equal to A2 into B2. So pi by 4 capital D square into B1 is equal to pi by 4 capital D2 square into B. So pi by 4 cancel and B2 is equal to D capital D divided by small d square into B1. So capital D given 10 mm which is equal to 0.01 and small d given 1 mm. So this is converted into meter 001 square into velocity given 10 mm per second which is equal to 0.01 meter per second. So calculating this we can get V2 is equal to 1 meter per second. So next apply Bernoulli equation between 1 and 2. V1 by rho g plus V1 square divided by 2g plus Z1 is equal to V2 by rho g plus V2 square divided by 2g plus Z2 as head loss is 0 and the datum line Z1 and Z2 is same plane and the vertical distance is not 0. Vertical distance is 0, so Z1 is equal to Z2 and P2 is atmosphere. We take the gauge pressure, so P2 will be 0. Next we have to found P1 by rho g plus B1 square divided by 2g equal to B2 square divided by 2g. Imply that P1 is equal to B2 square minus B1 square divided by 2g into rho g. G cancel and B2 value have to put 1 meter per second square and B1 given 0.01 square divided by 2 and density given 1000. So P1 is equal to 499.95 Newton per meter square and the force is equal to pressure into area. So the pressure given P1 for 499.95 and area is 5 by 4 into D1 square. D1 is 10 mm which is equal to 0.01 square. So the answer will be 0.0392 which is equal to 0.04 Newton. So option B is the correct answer, 0.04 Newton. Next, water is flowing through a horizontal pipe of diameter 200 mm at a velocity 3 meter per second. Circular solid plate of diameter 150 mm is placed in the pipe to obstruct the flow. Next, what is the loss of head due to obstruction of the pipe if CC coefficient of contraction is given 0.62 and taking G is equal to 9.81 meter per second square. So head loss formula we know A capital A CC into capital A minus small a minus 1 whole bracket square by 2G. So putting the value A capital A is pi by 4 into 200 mm given convert into meter 0.2 meter square and small small a is solid plate diameter pi by 4 into 0.15 square and cc given 0.62 and velocity given 3 and g given 9.81. In all the value we can get the head loss is 3.269, which is equal to 3.3. Option A is the correct answer. Next, question number 94. A flat plate of 0.1 meter square plate is pulled at 30 centimeter per second relative to another plate located at a distance 0.01 centimeter from it. The fluid separated then being water with viscosity given 0.01 Newton second per meter square. Then the power required to maintain the velocity will be. This is the difference between the plate and the datum line, and we have to find the power required to pull the plate. Given velocity given 30 centimeter per second, that means 0.3 meter per second, and the distance given 0.01 centimeter in that means 10 to the power minus 2 meter, and the given viscosity 0.0001 Newton second per meter square, and the plate area given 0.1 meter square. So from Newton's law of viscosity we know tau is equal to mu v by h, where mu is viscosity and v is velocity, and the h is the distance between two plate and the atom lines, and assuming the profile is linear for a small distance. And the force is equal to tau into area So force is equal to tau into area, implies that, and the power is equal to tau into area into velocity. So putting the tau value, mu b by h into area into velocity. So the power is equal to mu b square divided by h into area. So mu, putting all the value, mu is given 0.001 into velocity given 0.3 square, and area is equal to 0.1 meter square, and h given 0.01 into 10 to the power minus 2 meter. So by calculating above, we can get the power required is 0.09. So option C is the correct answer. Next, question number 95. When the pressure of a liquid is increased from 3 meganewton per meter square to 6 meganewton per meter square, and its volume decreased by 0.1%. Next, we have to find the bulk modulus of elasticity of the liquid. Just a minute. So we have to find the bulk modulus of elasticity of the liquid. So the bulk modulus A, which is delta P divided by change in volume with respect to volume. So the pressure given 3 meganewton and P2 given 6 meganewton. So difference is 6 minus 3 is equal to 3 meganewton per meter square, and the volume given 0.1%. So the converting to Newton per meter square, 3 into 10 to 6 meter square, and the change in volume given 0.1%, that means 100. So the answer will be 3 into 10 to 6 divided by 0.001. So the answer will be 3 into this 3 is 6 plus 10 to the power 9 Newton per meter square. Option B is the correct answer. Next, a flat plate of area 1.5 into 10 to 6 mm square is pulled with a speed of 0.4 meters per second to another plate located at distance 0.15 from it. What is the power required to maintain the speed if the fluid separating them is having viscosity 1 poise? 1 poise is equal to 0.1 Newton per Newton second meter square. This is the same case as question number 94. I have to apply this formula. Power is equal to force into velocity, and force is equal to mu v by h into area into velocity. So putting all the value, mu given 0.1 and velocity given 0.4, and area of the plate is 1.5 cm square 10 to the power minus 3 into 10 to minus 6 into 10 to the 6 0 is equal to 1, so 1.5 meter square, and velocity again 0.4 and h 0.15 mm, which is equal to the power minus 3 meter. So calculating above, then get the power is 160 watt. So option A is the correct answer. Next question number 97. A fluid viscosity 0.7 Newton second meter square and specific gravity 1.3 flowing through a circular pipe of diameter 100 mm and the maximum shear stress at the pipe wall is given as 196.2 Newton per meter square. Then what is the pressure gradient of the flow? So from the pipe equation, shear stress is given tau is equal to minus del p by del x into the radius of the pipe r by 2. So the shear stress given 196.2 and the pressure del p by del x I have to calculate it, and the radius is given 50 into 10 to the power minus 3, and the pipe diameter is 100 mm, so the radius is 50 mm. 50 mm that means 50 into 10 to the minus 3 meter, and r by 2. So we have to find del p by del x is equal to this negative sign 196.2 into 2 divided by 50 into 10 to the power minus 3. So the answer will be minus 7848 Newton per meter square per meter. So answer will be minus 7848 Newton per meter square per meter. Option B is the correct answer. Next question number 98. Consider a steam power plant using a reheat cycle as shown in figure. Steam leaves the boiler and enters the turbine at 4 megapascal and 350 degrees centigrade. S3 given 3095 kilojoule per kg. Next, after expansion the turbine to the 400 kilopascal, S4 given 2609 kilojoule per kg. Next, the steam is reheated to 350 degrees centigrade and S5 given 3170 kilojoule per kg. Then expanded in the flow pressure turbine to the 10 kilopascal, S6 given 2165 kilojoule per kg. Next, we have to find the thermal efficiency of plant neglecting pump work. So the turbine work is equal to S3 minus H4 plus H5 minus H6. S3 minus H4 plus H5 minus S6. This is unit is kilojoule per kg. So putting in all the value, S3 given 3095, S3 H4 is given 26095, 2609, and H5 given 3170, and minus S6 given 2165. So calculating above, the answer will be the turbine work will be 1490 kilojoule per kg, and the heat supplied is 3 minus H2 plus H5 minus H4. Heat supplied is 3 minus H2, and this is reheat also, H5 minus H4. So H3 given 3095 minus H2 is equal to H1. So given not mentioned, so this is pump work is neglected as given. So H1 is equal to H2. So 29.3 plus H5. H5 is 3170 minus H4. H4 is 2609. So calculating above, we can get the heat supplied is 3626.7. So thermal efficiency and thermal is equal to turbine work as pump work neglected, turbine work divided by Q supplied. So turbine work is 1490 divided by heat supplied is 3626.7. So calculating efficiency will be 0.411, which is equal to 41.1%. So option B is the correct answer. Next, question number 99. The vapor compression repetition cycle is represented as shown in the figure, with the state 1 being the exit of the, this is the exit of the evaporator. This is evaporator, and this is the vapor compression reaction. That means this must be compressor, and this is condenser, and this is the throttling valve, and the coordinate system used in the figure. So the evaporator and the condenser is work on the constant pressure process, and this is the, and 3-4 is enthalpy process. So this must be enthalpy line, and 2-3 and 4-1 will be constant pressure line. So this cannot be pressure, and this also 4-1 and 2-3 pressure constant remain constant, and also temperature remain constant. Pressure remain constant. So as 3 and 2 are different type of pressure, so we have to choose TH. So this cannot be pH, so the answer will be temperature. As 4-1 is temperature, and 3 and this step is constant temperature, and 2 and 3 are different temperature. So the y-axis will be temperature, and the 3 and 4 are isenthalpy process, expansion process. So this must be H enthalpy line. So option D is the correct answer. Next question number 100. The value of enthalpy of a steam at inlet and outlet of steam turbine Rankine cycle are 2800 kJ per kg and 1800 kJ per kg respectively. And neglecting pump work, the specific steam consumption of the in kilojoule per kilowatt hour. So specific steam consumption SS SSC given W net divided by 3600. So W net given the turbine inlet and outlet 2800 and 1800. But differentiate, we can get 1000. 2800 minus 1800. This is 1000 divided by 3600. This 0000 cancel. Sorry, I write the reverse manner. So specific steam consumption is formula is 3600 divided by W net. So 3600 divided by W net is 2800 minus 1800, which is 1000. So 2 cancel, and answer will be 36 kilojoule per kilowatt hour. So option A is the correct answer. Next question number 101. Steam enter an adiabatic turbine operating at steady state with an enthalpy of 3251 kJ per kg and leaves a saturated mixture 15 kPa with quality disscussion is given 0.9. The enthalpy of saturated liquid and vapor at 15 kPa are HF given 225.94 kJ per kg and HG given 2598.3 kJ per kg respectively. And the mass flow rate of the steam given 10 kg per second, and kinetic and potential energy are neglected. And they have to found the power output of the turbine in megawatt. So we have to found given H1 given 3251. This is the turbine. Let's take this turbine for this question. This H1 given, and H2 we have to found, and H2 will be HF plus disscussion X into HFG. So HF given 22 5.94 plus X disscussion given 0.9, and HFG is equal to HG minus HF. This is 2598.3 minus 225.94. So calculating, we can get H2 is equal to 2361.06, and H1 given 3251. So and mass flow rate, so turbine work is equal to H1 minus H2 into mass flow rate. So H1 given 3251 minus H2 given 2361.06, 2361.06 into 10th. So the answer will be 8899.4 kilowatt. So megawatt 8.89, which is equal to 8.9. So option B is the correct answer. Next, which one of the following statement is correct? In a water tube boiler, water is surrounded a tube and hot gas are inside. No, water is inside the tube and hot gas outside. So option A is the correct, incorrect. Next, the boiler which produce steam at pressure of 10 bar and below are called a high pressure. No, this is low pressure boiler. This is also incorrect. Langan style boiler are external fire. No, this is internal fire. Next, option D is the correct answer. Stirling boiler are external fire boiler. ठीक है. Next, 103 question number. In a power plant, the efficiency of electric generator, turbine mechanical, that means turbine mechanical, and boiler cycle and overall efficiency given 0.97, 0.95, 0.92, 0.42, and 0.33 respectively. And what is the percentage of total electricity generated in the consumed in running auxiliary? Unnata overall efficiency formula is equal to total NG efficiency of generator and efficiency of thermal efficiency, and efficiency of T means turbine, sorry, and efficiency of boiler, and efficiency of cycle, and efficiency of auxiliary. So overall efficiency given 0.33, and efficiency of generator 0.97, and efficiency of turbine given 0.95, and efficiency of boiler 0.92, and efficiency of cycle 0.42. And we have to calculate efficiency of auxiliary. So efficiency of auxiliary is the only unknown. So efficiency of auxiliary will be 0.926, and the electricity generated for running the auxiliary will be 1 minus efficiency of auxiliary 1 minus 0.926, which is equal to 0.074, which is closely equal to 7.32%. Option C is the correct answer. Next, question number 104. The ratio of Euler's buckling load of a column with the same parameters having both end fixed and both end hinged. So Euler's buckling load formula is equal to pi square EI divided by L effective length square. So all the parameters are constant except effective length. So it is inversely proportional to 1 by L effective square. So both the end fixed. In case both the end fixed, L effective will be L by 2, and both end is L effective will be L. So first case divided by second case, PA divided by PB will be 1 by L by 2 square and L square. So L square cancel, 2 square will go to the numerator. So PA by PB will be 4. So option B is the correct answer. Next, in a power transmission, if the polar moment of inertia of a shaft is double, then the torque required to produce the same angle of twist. You know the formula: P by polar moment of inertia IP is equal to G theta by L. So the torque is directly proportional to for same angle of twist and the material, and same angle of twist produced P is directly proportional to polar moment of inertia. So if the polar moment is double, then torque will be double. So answer will be option D, double the original value. Next, which one of the following represented by the area of shear force diagram from one end up to given location on the beam? So bending moment at the location is given. So answer will be option A. Next, in a piston rod and the crosshead in a steam engine are usually connected by means of. So it is usually connected by a cotter joint. Option A is the correct answer. Next, question number 108. A body having weight of 1000 Newton is dropped from a height of 10 centimeter over a closed coiled helical spring of stiffness 2200 Newton per centimeter. Then the resulting deflection of the spring is nearly. So conservation of energy, the potential energy given mg h and the drop height is x is equal to half the kinetic energy k spring energy kx square. So putting all the value, given mass mg given, that is 1000, and the height is given 10 centimeter, and x the deflection we have to found, and the half, and the spring stiffness is 200 Newton per centimeter, and x square we have to found. 1000x is equal to 100x square. This is the equation we have to solve. After solving this equation is dividing both sides will be 100, so it will be x square minus 10x minus 100 is equal to 0. So solving the following equation, we can get 16.18, the answer will be 16.18, which is closely 16 centimeter. Option B is the correct answer. Next, question number 109. A key connecting a flange coupling to a shaft is likely to fail in shear. Option A is the correct answer. Next, question number 110. In a plate cam mechanism with reciprocating roller puller, the following case has constant oscillation in the case of parabolic motion. Option B is the correct answer. Next, 111. When a two shafts are neither parallel nor intersecting, the power can be transmitted by using spiral. So a pair of spiral gear. Next, if a momentum of a given particle is double, then the kinetic energy will be. So the momentum P is equal to mass into velocity, and kinetic energy is equal to half mv square, and we can write half m square v square divided by m. So it is equal to half p square by m. So the kinetic energy is double, means square. So the kinetic energy is double, then 2 square is equal to 2, that means 4. So option B is the correct answer. Next, the power required by a machine having efficiency 80% for raising a load of 24 Newton through a distance 36 meters in 1 minute. So the power will be 24 Newton into meter will be, distance will be 36 meter divided by, and in minute given 60 divided by efficiency given 80%, 0.8. So calculating it, you can get in watt. So option B is the correct answer. Next, question number 114. Which one of the following statement is correct? Energy and work are scalar. No, force and work are vector. Energy, momentum, velocity are vector. So option C is the correct answer. Energy, momentum, and velocity are vector. Next, question number 115. Consider the following statement. Two couples in the same plane can be added algebraically. Coplanar and concurrent forces are one that neither lie in the one plane or nor meet at a point. Next, non-concurrent forces are the one that do not meet at a point. Next, a single force may be replaced by a force and couple. So this option is incorrect. Next, remaining 1, 3, and 4 will be correct. So option D is the correct answer. Next, question number 116. The reaction in kilonewton at a support A for a beam shown in figure. So we have to find the reaction array. Reaction at support A. Next, let's take a moment at B. 0. Array into 6 plus 4, 10. Plus 10 into 5 is equal to 8 into 4. So 8 into 4 is equal to 32 minus 50 is equal to 18, and array is equal to 18 divided by 10 is equal to 1.8, and this is the negative as we assume the direction that side. So the negative will come, that means the direction will be that side, downward side. So answer will be 1.8 kilonewton. Next, question number 117. The figures show the loading pattern on the stress force in member SC. The answer will be 0. This is a doubt question. Maybe 0. This is statically indeterminate. This is option no. Maybe 0. Next, question number 118. These dimensions are not given. If assuming this dimension 1 unit, this is 1 unit, and this is 1 unit, and we can get the force in AC from method of joint. FAC will be 12 by 5t, and none of the options are matches, so we can. This is ambiguity question. That means maybe 0. Next question. Question number 1 and 8. The block shown in figure is kept on equilibrium and prevented from sliding down by applying the force of 15,500 Newton. The coefficient of friction given √3 by 5, and the weight of the block. This is W sin 30. Sorry, this is W cos 30. W sin 30. And the friction is acting to prevent the sliding motion is downward. So F is equal to mu into N. N means W cos 30. So force balance in this direction. √500 plus mu given √355. W cos 30 is given √3 by 2 is equal to W sin 30 is 1 by 2. So calculating that, we can get W will be 2500 Newton. Option B is the correct answer. Next, question number 119. The motion of a particle, distance in meter and time in second, is given by the equation S is equal to 2tq plus 3t, starting from t is equal to 0 to attain a velocity of 9 meter per second. The particle will have to travel a distance of. So given S is equal to 2tq plus 3t, so the velocity will be 60 plus 3, and from at time t is equal to 0, velocity will be p, and at what time velocity will be 9. So velocity will be 9 at time is equal to t is equal to 1, 6 into 1, 6 plus 3. So time is equal to 1. So putting the value t is equal to 1, 2 into 1, 2 plus 3 into 1, 3, 3 2 plus is equal to 5. So option A is the correct answer. Next, question number 120. In a figure, two bodies of mass m1 and m2 are connected by a light extensible spring passing over a smooth pulley. Mass m2 lies smooth horizontal plane. When a mass m1 moves downward, the oscillation of the two bodies means the mass m1 moves downward. First balance in the body m1, m1g is equal to t. Next, for body 2, m1a minus t is equal to, just a minute. This is the direction. m1g minus t is equal to m2a. So putting the value t in the equation, m1g, sorry, this will be not. So this is equal to, from this body, m2a is equal to tension, this t, and from this type we can write m1g is equal to m2a plus m1a. Yes, tension So solution will be m1g divided by m2 plus m1. So m1g divided by m1 plus m2. Option A is the correct answer. Next, question number 121. A person carrying on his head a jewelry box of weight W, jumping down from the third story of the building. Before touching the ground, he would feel a load of. Before touching the ground, there will be a load acting in the downward, and the reaction will be R, and where the pseudo force will be act before touching ground, the pseudo force will be equal to the W type. So W cancel, the reaction force will be 0. Next, question number 122. Cord is wrapped around the cylinder of radius r and mass m is given shown in the figure. If the cylinder is released from the rest, the velocity of the cylinder after relaxed move through a distance h will be. Let's solve in the another page. We know velocity is equal to r omega, and omega is equal to v by r. This is the cylinder acting w, and this is the omega. This velocity. So at position 1, kinetic energy is equal to 0, and cylinder had just fallen through the distance. So kinetic energy at position 2 is equal to half mv square plus half I omega square, rotational energy. So I mv square plus I means half mr square, the moment of inertia of cylinder, and omega is equal to v by r square. So by solving this, we can get 3 by 4 mv square. Next, principle of work and energy theorem. Kinetic energy plus work in 1 to process 2 is equal to kinetic energy of 2. So first kinetic energy given 0, and work done is mgh is equal to 3 by 4 mv square. So the velocity will be v square is equal to 4 cancel, 4 gh divided by 3. So velocity will be root over of 4 gh by 3. Acting downward. So option C is the correct answer. Next, what is the work done if a bucket of water weighing 10 Newton is pulled up from a well of 20 meter deep by a rope weighing 1 Newton per meter? So this is the 10 Newton, and the well 20 meter deep, in rope is 1 Newton per meter. So the area, it is uniformly varying load, so the total area will be half base into height. So base is equal to 20 meter, and the weight is given, the height is 1 meter. This is the rope, and as the length increases, the load also increases. This is uniformly distributed load, so the area under the curve is given the total weight. So total weight will be 10 plus 10 is equal to 20 Newton, and the work done will be 20 into the distance is 20, it's equal to 400 Newton meter. So option B is the correct answer. Next, question number 124. two mass of 2 kg and 8 kg are moving with equal kinetic energy. The ratio of magnitude of the momentum. So the kinetic energy is equal. That means half m v1 square m1 v1 square is equal to half m2 v2 square. Half cancel. M1 given 2 and v1 square is equal to 8 v2 square. So v1 by v2 is equal to 8 by 2 is equal to 4. 4 root over is equal to 2. So v1 by v2 is equal to 2. Then we have to find their momentum. Momentum v1 by v2 is equal to m1 v1 divided by m2 v2. So m1 given 2 and m2 given 8 and v1 by v2 is equal to 2. So this is equal to 4 by 8 is equal to 1 by 2 is equal to 0.5. So option B is the correct answer. Next, from question number 125, we solve from next class. So thank you.